Advent of Code, day 18. Okay. Um, hmm. Oh, are we making a... Okay. Okay. To the exit, and exit is bottom right. Okay, so we're going from upper left to lower right. Gotta be. Okay. Um, yeah. Okay. Um, um, yeah, that. Okay. They order the land in your memory space. Oh, 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 that's interesting. Okay. That is interesting. So we have the state is actually going to be a little more interesting. Um, yeah. Um, yep. And then, Mm. Yeah, so it's actually not that. We don't even need the grid. I'll keep that anyway. This is actually all true. These are fails. Yeah. So actually, um, yeah, and then fail. Okay. Okay. I'll just make it easier for testing. Um, in data time, I think. Feel like that's going to be +1. Feel like that's going to be +1. Um, so we're going to set this to 6. It's 12. No. Or they'll fall. Oh, simulate the first kilobyte failing. Oh, falling. Okay. I see. Okay. And then I actually still did that. Wonky. I don't even need time, but sure, we'll do that. 22. Okay. So we have 70 in the first 1024. Yeah, because the times. Yeah. Wonder if I accidentally started doing part 2. That would be interesting. Okay. First byte that will cut off the path to the. Oh. Um. Oh, okay. That's not bad. Um. Um. Sure. Graph? No. Grid. Um. Passing in the grid. Do. This is just awful. That. And if this in. That failed. Do. Okay, so we get the grid. Dimension is fixed. Falling by, okay. Um, yeah, for I. I plus 1. Mm-hmm. Do you know what? How many do I have to search through? That's a lot. So, binary search time. Um, yeah, okay. So, what I was starting to do here was a binary search, but my brute force finished. How much did I miss by other than yes? 555. Yeah, I missed by a lot. I overcomplicated this one. Um, yeah, that's the price of rushing. Thankfully, my graph library is pretty robust, and I can very easily make new graphs, which I've shown in some previous problems. But yeah, let's just talk about this problem. Uh, so we have a grid, and wow, grids have been a theme this year. We've got a grid ranging from 0 to 70 in both directions, and we're trying to get from the start position, upper left, to the end, lower right. But we have a certain number of bytes that are just failing. And that is our giant input, which apparently we have nearly 3,500 of those, which is, quite a lot. Then we're trying to figure out in the first part if the first 1024, the first kilobyte of those bytes fail, what is the length of the fastest path from that start to the end. That's just standard searching, depth first search, uh, or well, I guess breadth first search rather, or Dijkstra's work just fine. I always go to Dijkstra's because I've got that implemented in my graph library. So yeah, the issue I made here, or the issue I had here, is I was first thinking I was just speedrunning here, and I was thinking, oh, list of which bytes will fall, and I was thinking, and in the order, and I was thinking, oh, so this means that every step another byte is going to fail. So I was going to do something really complicated where I kept track of the time, which is completely useless, increment the time at each step, and then check to see uh, in the in the list of failing bytes is the one that is failing uh, in in the first n bytes in that time span, so that we can be outrunning those bytes, which seemed like what was being asked. It was definitely not what was being asked. We have a fixed number of bytes here that are failing the first kilobyte. So yeah, after doing that, I don't even know if I got an answer there. Um, I was getting -1 because that apparently this isn't configured to give me an answer for that. Uh, so yeah, after I actually solved the correct problem, just checking for the first kilobyte of bytes, uh, this just gave me the path, and that's the answer, plain and simple. I am definitely going to go, and before I publish this, I'm going to clean this up, get rid of these extra variables that really have no business being here. My neighbor function here and checking if it's in the grid is overly complicated. I should be checking just x's in the correct range. I don't even need this grid because at first, actually the first issue I had is I thought these were going to be either the live bytes, the ones we could step on, or the ones we couldn't. Again, that was not what the problem was. Though I guess I could probably make use of that. There is a world where I make use of that in one of the refactored, one of the ways I could refactor this solution. I'll have to think about that going forward. Anyway, then for part two, instead of taking a fixed number of bytes and seeing what the shortest path is, we need to find, okay, in the giant sequence of nearly 3,500 bytes, which one, when it fails, blocks our path from the start to the end. Uh, there, I almost wonder if there's a nice, efficient DP approach to this where we already have the answer, we block off a path, and then we know what we need to affect and how to propagate that change. There might be a way to do that. I am not going to think through that now, and it's not really necessary because you can't just keep trying all these blocked paths, blocked bytes, and just throw Dijkstra's at it and see if it converges. For my implementation, if it doesn't converge, I return -1 as the number of steps. So yeah, I've just got this very simple, is solvable predicate, pass in the graph, or rather the grid and the failing bytes. Again, I need to clean this up. I've got no use for a grid, at least with the approach I was coming up with. And then just keep trying bytes until I find the one that is failing. I did see this was taking some time. Actually did, like it was running here. I don't know how far it was, but I saw it was taking time, so I just wanted to see how long it was going to go. So I did restart it, wasted a little bit of time there conceptually. And I was about to start, and I had started writing a binary search here because just the sequence here, we know if we take all the bytes is going to fail. We take none of the bytes is going to pass. We can find a path. Somewhere in the middle is where it breaks, and we can binary search to find where that point is. And that's going to run in logarithmic time, logarithmic number of attempts. So this is definitely going to be my first cleanup pass, is just doing this more efficiently instead of a brute force linear search. But I cannot type as fast as my computer can compute. Computer found the answer, submitted it, got my answer. So yeah, definitely would have liked to have been faster, but I still have 7 more days to try and get a leaderboard point. So I'll be back tomorrow trying to get those leaderboard points.